Okay, so aldehydes and ketones, part 5, the Grignard reagent. The Grignard reagent is simply this part here, magnesium bromide, and the CH3 is the R group. So this can also be viewed as a CH3 minus, where any R group here would be the minus, and the Mg magnesium bromide will always be the positive. And so since this is the negative, it is the nucleophile, which will be attacking the aldehyde or ketone, kicking those electrons up on the oxygen, making it negative. So since this becomes negative, it is lacking that proton, and so the next step would be to do a proton transfer. That's why this water is here. This water can also be an H3O+. It's just, I think it's a base just to remove that proton to get protonated. Simply just to do the proton transfer step is why that's here. Part 2 specifically. And then you have the alcohol after getting protonated. Now you might be wondering, well, what happens to this proton? Well, it's still there, it's just right here and it's not drawn in. So this technically could have been drawn just like that, and it's an aldehyde, it's the same exact thing. But now since the CH3 attacked, that is what is right here, your CH3. Now regarding stereochemistry, because your magnesium bromide, your CH3, could have attacked from either position, the front or the back of this aldehyde here, then that means that your OH, your alcohol, can be either on a dash or a wedge. So let's draw that in. There we go, we drew it in here, and this is what it's gonna look like. Whenever you have two products where one is wedged and one is dashed, that is going to be called a racemic mixture. Now back to saying that this was behaving as a base, that is completely wrong. It is actually behaving as an acid, and only acids can participate in proton transfers simply because acids are what donate protons and bases accept protons. And so with water being an acid here, water can behave as an acid or base. That's why it can seem a little bit confusing. But with H3O also being a possibility, H3O is 100, H3O plus is 100% an acid, and they will always, always, always donate a proton. So anytime that you see H3O plus here, or like something like water, know that you have a proton transfer step, which likely means if you have an oxygen, you're going to end up with an alcohol.